Alright, here is the chapter test, the first take on it of part 1, and I'll walk through each of these for you, trying to do it quickly. Problem number 1, if you look at it right up here, we're supposed to just find out which one of these it's equivalent to. And so I'm going to do that. Well, I'm going to start on the innermost set of parentheses. If you notice, it says to square that stuff, and that'll help eliminate some of the mess that we have. So let's see if I can write these things correctly. That's 4p to the 6, q to the 5th, over, and now I've got to square everything down there. So I square the 6. I got to take p to the 5th times p to the 5th. Shortcut is you just take 2 times 5. Or you can think p to the 5th, p to the 5th. I add exponents. It's going to be p to the 10th. Q cubed, I square that, so I multiply 3 times 2. Okay, and that's still all to the negative 2 power. Then what I'd like to do is simplify these fractions a little bit. We've got a lot of stuff going on there. So like 4 over 36 simplifies to 1 over 9. At 6 p's on top, 10 on the bottom, that means I've got an extra 4 in the bottom. I got 5 q's on top, 6 in the bottom, which means I've got an extra q on the bottom. And that's all to the negative 2 power. This negative means flip it over. So my 9p to the 4th q goes to the numerator. And I could put the 1 on the bottom, but I don't need to. But it does say to now square it. So it's 81p 8q squared. And you can see that matches our first answer. Alright, so let's move on to the second problem here. And there it is. Just got to get it all in there so you can see it. Let's find the perimeter of the rectangle, and they tell us its sides, 3x plus 2 and 4x plus 3. Correct that, 4x minus 3. Well, recall a perimeter means add up all the sides, and since we're dealing with a rectangle, we just have to add up 2 lengths, 3x plus 2 plus 3x plus 2, and 2 widths, plus 4x minus 3 plus 4x minus 3. And I wrote over a few of my notes there, but we can see that it's pretty easy to add up all the x stuff. That's 8, 9, 10, 11, 12, 13, 14 x's. And then add up all the constant stuff. That's a 4 and a negative 6, so it's minus 2. And there we go. And we can see clearly that's answer D, 14x minus 2. Alright, continuing on to problem number 3, the rectangle has a side of 3x plus 2, 4x minus 3, same as before, but now they say find the area. Area for a rectangle is length times width. So we take our length times our width. It doesn't matter what the expressions are, that's how you calculate area of a rectangle. And so we distribute the 3x, that's 12x squared minus 9x. We distribute the 2, it's 8x minus 6. We combine our like terms right there, so I'm going to get 12x squared, a negative 1x minus 6. And that looks like answer C right there. Alright, let's move on here to number 4. Number 4, they tell us we have a swimming pool, and we're going to put a deck around it. So I'll let red be my swimming pool. Put my deck in a nice brown color. And they say this deck is going to be width x. So that's this distance here. Okay? And it's going to be that width all the way around. Well, that means if I kind of break this deck up, this strip right here of the deck would be x long. This strip of the deck would be x long, or x wide rather, not x longs. This one, and then I have this little short section. So I kind of broke it up into 4 sections. And I know quite a bit about these sections. I know, for example, the pool is 30 long, so I know this distance right in there. And I know this little distance right there is x and x. I can actually find the area of this top section. Its total length is 30 plus the 2 x's on the end, and its width, this distance right here, is x. So length times width again gives me area. So 30 plus 2x times x will give me the area of that top strip. That's 30x plus 2x squared. Now to make my math easy, I'm going to finagle my drawing a little bit. I'm going to say, well, if I know that top strip, I actually know this bottom strip. It's going to be 30x plus 2x also, or 2x squared. So I can add those two together. That's the top strip and the bottom strip added. And so the last two strips I have to add are this and this. But they're part of the deck, and the deck is x wide, and they follow right along the edge of the pool, which is 20 tall. So each of these is 20 for height times x width. Each of those are 20x in area. Again, length 20 times width x. That gives me more area. That's 40 x's when I add them to this down here. And I get a total area of 4x squared plus 100 x's. That looks like answer B, 4x squared plus 100. Now that's not the only way to solve that problem. You can break it up in several ways. You can do the entire area and then subtract off the hole for the swimming pool in the middle. Any of those methods work. Number 5, find the area of a square. Squares have the same length and width. So I just take 4x plus 2 times 4x plus 2. We had a shortcut for squaring binomials, if you remember it. Square the first term, multiply the two terms and double them. That's 8x doubled, 16x, and square the last term, 4. Now if you don't remember that, you can just write 4x plus 2 times 4x plus 2 and FOIL them together. But 16x squared plus 16x plus 4 is our result. And then finally the last one on the first page, and then I'll stop and make another video for the rest. This last one was the most missed problem on the test, and I think the key word here, and I don't like this on tests, but it's important for us to read the entire problem. Okay, it's in italics. Okay, that's going to be especially important on the park. We want to know it's equal to all of these except for which one. So first thing I would do is say, well, I'm dividing by a monomial down here. And we learned in class we just separate each term in the numerator and put it over that denominator. To the 4th x cubed minus 15w 4x cubed over 6x to the 4th x cubed plus 27w cubed x squared over 6x to the 4th x cubed. And then we simplify each of these. So 18 over 6, that's 3. There's a w to the 4th down there. We got an extra w in the bottom and an x squared on top. Next term, 6 over 15, they're both divisible by 3, so that's 5 over 2. W's are equal, so that's just a 1. X's are equal, so that's just a 1. And then the last term, 27 and 6 are both divisible by 3, so it's 9 over 2. Extra w again. Extra w on the bottom, and extra x on the bottom as well. So there's the three terms I get when I simplify it. So I start looking through these, and the first one I pick up on is b. 3x squared over w, it's got a negative 5 over w, has a 9 over 2w squared. So that is equivalent to what I started with, so that is not my answer. The next one, I'm going to do A last because that turns out to be our answer. The next one, if I look at that, I can see I could separate. Notice this is a binomial on top, a monomial on the bottom. So I could separate those two, put them both over the denominator. This 9 over 2 and then this w to the negative 1, x to the negative 1, that means put me in the denominator. And if I simplify this, I get 3x squared over w minus 5 over 2 plus 9 over 2wx. Again, that's what I ended up for an answer. So I can simplify C to get the same result. And then finally D, I would do exactly the same thing. This one just hasn't been simplified all the way. But if I break up D, I'd have 6x cubed over 2wx minus 5wx over 2wx plus 9 over 2wx. Simplifies to 3x squared over w. If I erase b's cover up there, you can see that was the first term of the answer I got. It would be 5 over 2, a negative, had that one in my answer, and the last one 9 over 2wx, had that one. So this one is also equivalent. So our answer to the one that is not is A. Okay, if you tried to separate A, okay, that numerator 6x cubed over 2wx, and 9 over 2wx, it's that 6x cubed, no, it's actually the last term that throws us off. We should just get negative 5 over 2, but A has negative 5w over 2. And so for 6th, answer A is the one that does not work. All right, that will end this one. Then I will do side 2 at a later